Hi, this is Mrs. Sigala, and this is your homework 5.1 for unit chemical quantities. Okay, and so first and foremost, before you begin, you're going to need your periodic table of elements. You will need your calculator, okay, because we're going to start off with molar mass. All right, so molar mass is like the first step to beginning this unit, talking about molar chemical quantities. If you don't understand molar mass, you're going to really struggle in this unit. So, again, it's very basic. It's just a matter of staying organized as well. And so to find the molar mass, you'll be using the atomic mass. Don't worry about rounding. I'm not sure why that says to round, so I'm going to cross that out. So when I look at my periodic table of elements, I look at sodium chloride, and here we have two elements. And so here, I have, based on my formula, since there is no subscript, I know that I only have one sodium. Usually kind of write this in parentheses. And I have one chlorine. So I'm going to look at my atomic mass, and based on my periodic table of elements, sodium is 22.990. Chlorine is 35.453. Now my molar mass for sodium chloride, I have to add these, so it's going to be 58.443. And my unit for molar mass will always be grams per mole. And in this case, we're talking about NaCl. Okay. Next, I have calcium hydroxide. And again, they're giving us the formula in this case. If they were to give us the name, then we have to figure out the formula, but we don't have to worry about that right now. So, calcium, according to our formula, there's no subscript, so we can assume that there's only one calcium. Now, in this case, we do have a polyatomic ion, and this polyatomic ion has a subscript of 2. So this 2 needs to be distributed to the oxygen and to the hydrogen. So in this case, we have 2 oxygens, and we also have 2 hydrogens. Okay, so now my atomic mass for calcium, according to my periodic table of elements, is 40.078. My atomic mass for oxygen, you can memorize this number, whether you want to or not, is 15.999. And for hydrogen, this is probably one that you'll memorize as well, 1.008. Again, we're dealing with very simple math, but you should still use your calculator to avoid any errors. So again, 40.078 times 1 stays the same, 40.078. 2 times 15.999, I end up with 31.998. And then 2 times 1.008, I end up with 2.016. Next, I have to make sure I add up all these, and my molar mass will be 74.092, and your unit grams per mole. Okay, so in this case, with this backslash, and as I was explaining to my students, I still have a lot of students that get confused with it. If I were to write this as a fraction, I would write it as 74.092 grams over, and in this case, we're talking about 1 mole. Okay, so don't get confused with that little backslash. The backslash, I'm sorry. Okay, so next they give us FeO3, or iron oxide. So again, the key to being successful in this case is staying organized. I have 2 irons, so I'm going to write down my symbol first. I have 2 irons. My periodic table of elements tells me that iron's atomic mass is 55.845. I have 3 oxygens. And again, that's 15.999. Now I do my math. 2 times 55.845 is 111.690. 3 times 15.999 is 47.997. I have to add these. My total is 159.687. And again, I'm talking about molar mass, so my unit will be grams per mole. In this case, we're talking about Fe2O3. Alright. My next one, this is where, again, nomenclature will affect you. If you didn't understand nomenclature, I strongly recommend that you go back to the past videos and review that. In this case, we're talking about ammonium phosphates. So here we have two polyatomic ions. So again, we're going to be crisscrossing oxidation or charges for everything except for covalent compounds. So first I'm going to write down my formula or my symbol for ammonium. And since it's polyatomic, I always like to use parentheses. Next, I have phosphate, that's PO4. When I look at their charges, I know that ammonium is +1 and phosphate will be -3. Again, we're going to be crossing these charges. So my final formula in this case will be NH4. Let me write it down here. And I'm going to keep it in parentheses because I have 3 of these. And then since there's only one PO4, I don't need parentheses. Alright, so that's my first step since I was given a name. Next, I have to make sure that I separate my elements. So for this one, I have nitrogen, I have hydrogen, I have phosphorus, and I have oxygen. Okay, and so again, since we have parentheses, it's just like in math, and we have this subscript, we're going to have to distribute this subscript. So in this case, I have 3 nitrogens. I also have to distribute this 3 to this hydrogen, but I already have 4 hydrogens, so it's actually 3 times 4. So in this case, I end up with 12 hydrogens, 1 phosphorus, and I have 4 oxygens. Nitrogen's atomic mass is 14.007. Again, hydrogen's is 1.008. Phosphorus is 30.974. And again, I'm getting these numbers from the periodic table of elements. And oxygen is 15.999. Okay, now I'm going to do my math. 3 times 14.007 will give me 42.021. 12 times 1.008 is 12.096. Here we're just multiplying by 1, so this number stays the same, but I always rewrite it just to make sure my numbers stay organized. And we have 4 times 15.993, we have 63.996. Okay, next I have to add all these. When I add them, I'm going to have to write really small. I end up with 149.087. And again, my unit is grams per mole. And I'm talking about ammonium phosphate. Okay, we have 2 more. Next we have aluminum sulfates. And here we don't have to figure out the formula. Thank goodness it was given to us. And so again, we're starting off with aluminum. And I always go in the order of my elements from left to right. So I start off with aluminum. And here I have 2. Now, let me erase this real quick so you can see what I'm about to do. Here we have parentheses, and so again we have to distribute this subscript. So I'm going to end up with 3 sulfurs. And I have 4 oxygens, but then the subscript is 3, so I have to multiply that times 3. So 4 times 3 is 12. Again, my atomic mass for aluminum is 26.982. For sulfur, my atomic mass is 32.066. And for oxygen, 15.999. again, I'm going to do my math. 26.982 times 2 gives me 53.964. 3 times 32.066 gives me 96.198. And 12 times 15.999 gives me 191.988. I'm going to add all these, and that comes out to a total of 342.150, and my unit is grams per mole. And I'm talking about aluminum sulfate. Okay. Number 6, dinitrogen trioxide. Here, again, because I have these prefixes, I know it's a covalent compound. And so dinitrogen, that is 2 nitrogens. Trioxide, that's 3 oxygens. So that's my very first step. Now I'm going to separate them. I have 2 nitrogens. I have 3 oxygens. Nitrogen's atomic mass is 14.007. Oxygen, 15.999. So 2 times 14.007 is 28.014. 3 times 15.999 gives me 47.997. Again, I'm going to add these. Then I put the total of 76.011 grams per mole. And I'm talking about dinitrogen trioxide. Okay, next one. We have number 7. And just like in math, don't get confused with the word problems. Identify what information you need, what information you don't need. So number 7, an alien visits Earth. He brings with him an unknown substance. He says, I believe this substance like an earthly compound. It is either nitrogen dioxide or nitrogen trioxide. I'm not sure which. All I know is that its molar mass is 62.01. Which compound did the alien bring with him? And so in this case, we have to find the molar mass for both and compare to our given answer and see what this alien really brought. So the first thing that we need to do is take a look at these names and figure out what are my formulas. So nitrogen dioxide, again, we know we're talking about a covalent compound, nitrogen dioxide, so there's 2. And then my second one is nitrogen trioxide. Tri again means 3. So again, I'm going to organize my information. Nitrogen, I only have 1. Oxygen, here I have 2. So nitrogen's atomic mass is 14.007. Oxygen, 15.999. I don't know how I forgot that. I'm going to do my math. This one stays the same, 14.007, because there's only 1 nitrogen in my formula. And this will become 31.998. I'm going to add these, and my total will be 46.005 grams per mole. And here we're talking about nitrogen dioxide. Okay, so in this case, we know it's not nitrogen dioxide because, again, this answer does not match what this alien brought back. So let's see if it's nitrogen trioxide, just to confirm. So again, I'm going to organize my information. I have 1 nitrogen, 3 oxygens. Nitrogen's atomic mass, 14.007. Oxygen, 15.999. So again, 1 nitrogen, so it stays the same. But 15.999 times 3 gives me 47.997. And my total there, when I add them, is 62.005 0.004 grams per mole. And here we're talking about nitrogen trioxide. So now I compare my answer to what this alien brought. And yes, it matches. So in this case, this alien brought back nitrogen trioxide.